The Sun is the only star in our solar system. Viewed from Earth, it dons a deep orange hue in the morning, transforms into a brilliant white at noon, and blazes a vivid red in the afternoon. This wondrous beauty captivates the eye. But if you had the chance to approach the Sun at a distance of just a few million kilometers, like NASA's Parker Solar Probe, you would realize the Sun is not the serene body we typically observe from Earth. Instead, it resembles a giant, perpetually seething nuclear reactor. Occasionally, its dynamic magnetic field hurls colossal plumes of plasma into space, a phenomenon known as a coronal mass ejection, CME. These phenomena can produce spectacular auroras on Earth, but simultaneously cause power outages, radio wave disturbances, affect satellites, and disrupt communications. NASA's Parker Solar Probe has for the first time observed a coronal mass ejection, CME, providing an unprecedented look inside this fascinating solar phenomenon. So how is this story usually told? Let's explore it together. The Parker Solar Probe is humanity's first spacecraft designed to approach and study our Sun. This probe was launched on August 12, 2018, aboard a Delta IV rocket from the Cape Canaveral Air Force Station in Florida, USA. Over the past 5 years, the Parker probe has continuously orbited the Sun, and with each pass, it has drawn incrementally closer to our central star. Approaching the Sun too closely is extremely dangerous for any spacecraft. But Parker is a true hero. In fact, it once pierced through the Sun's atmosphere and survived spectacularly. However, that still doesn't seem to be the most dangerous experiment Parker has ever conducted. Recently, the spacecraft completed one of the boldest missions in its journey of exploration. That is flying through a coronal mass ejection, CME, an area considered one of the most dangerous places on the Sun's surface. To help scientists understand the formation process of a solar storm, this is the first time an eruption of such intensity has been recorded. Like most other experiments Parker had participated in, this one also proceeded quite smoothly. And indeed, the probe has uncovered crucial clues about the origins of solar storms. As we know, when solar storms impact Earth, they create brilliant, colorful, and utterly mesmerizing auroras at the planet's polar regions. However, if sufficiently powerful, these coronal mass ejections, CMEs, can impact Earth, causing power grid failures, disrupting satellite signals, destroying radio communication systems, and numerous other consequences. The Carrington event of 1859 is considered the most powerful and severe solar storm ever recorded in history. When one of the strongest solar storms struck, it actually scorched the equipment in telegraph offices and even electrocuted the operators. Therefore, the crucial clues gathered by the Parker Solar Probe will greatly aid in space weather forecasting, and to warn Earth in advance of any impending dangers, if they exist. NASA revealed that as it flew through a coronal mass ejection, CME, the Parker Solar Probe, equipped with its wide field imager, clearly captured turbulent eddies within this plasma cloud. Physicists call this swirling phenomenon the Kelvin-Helmholtz instability, KE. They believe that these KH phenomena occur whenever a fast-moving fluid mass interacts with another fluid mass. On Earth, this phenomenon occurs within clouds when the wind speed at one end of the cloud differs from that at the opposite end. On the ocean, different water layers also move at varying speeds. Physicists suggest that in the coronal mass ejection, CME, phenomenon, these instabilities occur when the plasma within the CME moves in the opposite direction to the background solar wind. However, they never had the appropriate equipment in the right location to observe these phenomena. This is the first time a spacecraft has recorded the turbulence inside a coronal mass ejection, CME, and it is a true treasure trove for solar physicists. Evangelos Paris, a solar physicist at Geomerson University, stated that this turbulence not only generates KEs but also plays a fundamental role in regulating the dynamics of the CME as it propagates through the surrounding solar wind. Therefore, capturing disturbances is key to gaining deeper insight into the evolution and dynamics of CMEs. We exist within the very atmosphere created by the Sun. Any fluctuation on the Sun could become an apocalyptic event for life on Earth. Therefore, monitoring and understanding the Sun's activity and space weather conditions are crucial ways to protect life on Earth. That is precisely the reason behind the launch of the first solar probe, Parker. During its planned 7-year mission from 2018 to 2025, the spacecraft will complete 24 orbits around the Sun, with its closest approach being approximately 6.2 million kilometers. The Parker Solar Probe is equipped with 4 scientific instruments designed to study magnetic fields, plasma, energetic particles, and capture images of the solar wind. The Parker Solar Probe and its scientific instruments are protected from the sun's heat by a 4.5-inch, 11.43 centimeters, thick heat shield made of carbon fiber composite. This shield can withstand temperatures of up to 1,377 degrees Celsius. Right now, as you sit watching this video, the Parker Solar Probe is plunging into the sun's atmosphere. It is enduring incredible heat to help humanity gather valuable data about our closest star. The ultimate goal is to study space weather to protect life on Earth, which includes both you and me. Touch. On February 28, 2021, the Parker Solar Probe made a deep dive into the sun's atmosphere. There, it collected particle samples and measured magnetic fields using a specialized instrument called the Solar Probe Cup. And touching the sun made the spacecraft glow red hot, but it survived spectacularly, making its name renowned far and wide. For the first time in history, the Parker Solar Probe has safely touched the sun without sustaining any damage. One of the secrets to Parker's survival is to strike and retreat as quickly as possible. Justine Casper, a scientist from the University of Michigan in the US, emphasized that the Parker probe was traveling at an extremely high speed, approximately 100 kilometers per second. In the past, Parker set the record for the fastest spacecraft in history, reaching a speed of 532,000 kilometers per hour, equivalent to approximately 147 kilometers per second. This mission is named after Dr. Parker, the pioneering scientist who laid the foundation for humanity's modern understanding of the sun. In the mid-1950s, while still a young professor at the University of Chicago, Parker developed a pioneering mathematical theory predicting the existence of the solar wind, a continuous stream of matter flowing outward from the sun. Throughout his career, Parker repeatedly revolutionized the field, pioneering novel ideas and answering fundamental questions about how the sun and the universe's stars operate. He passed away on March 15, 2022, at the age of 94. Prior to that, in 2018, he became the first person in the world to witness a spacecraft bearing his name being launched. After more than 5 years in operation, it is a delight that the Parker probe is still functioning well. NASA's Parker Solar Probe today continued its journey to fulfill its mission of answering the pioneering questions first posed by scientist Parker over half a century ago. We are living in the golden age of solar physics. In just 5 years, the Parker Solar Probe has completely transformed humanity's understanding of the sun and how its activity affects life on Earth. As we get closer to the sun's surface, we will discover more fascinating properties of this star. Simultaneously, significantly enhance the understanding of space weather as well as the capability to live and work in the space environment. At this point, the video from TOT2V will have to end here. Wishing you moments of relaxation and enrichment. And now, goodbye and see you all in the next videos. Goodbye and see you again.